Hi, Mr. Richards here. Today's lesson is on systems of inequalities. Our objective is to solve systems of linear inequalities by graphing and apply systems of linear inequalities. On our first example here, we have solved the systems of inequalities by graphing y is less than 2x plus 2 and y is greater than or equal to negative x minus 3. And what we have here first is the graph of the inequality y is less than 2x plus 2. You can see the dotted line shaded to the right. Our second graph, y is greater than or equal to negative x minus 3. You can see the solid line with the greater than or equal to shaded again up to the right. And what we're looking for now when we solve the system of inequalities is this intersection point here. All this area shaded here represents our solution for the system of inequalities. So let's solve the system y is greater than x plus 2 and y is less than or equal to negative 2x minus 1. If we graph the first inequality in red, we have a y-intercept of 2 and a slope of 1. So rise 1 over 1, rise 1 over 1, and so on. Also apply the same thing going down. And of course this is going to be a dashed line as we have just the greater than. And when it comes to testing out what direction we are shading in, since this does not go through 0, 0, we can test using the point 0, 0. So if we put in 0 for y and 0 for x, is 0 greater than 2? Well, no. So we shade the opposite direction of 0, 0, which is up this direction. What about our next inequality? Y is less than or equal to negative 2x minus 1. Well, here we're going to have a y-intercept of negative 1 with a slope of negative 2. So down 2, right 1. Down 2, right 1. Of course, we could go up to left 1, up to left 1, up to left 1. And this one's going to be a solid line as we have the or equal to. And when it comes to shading, again, we can test using 0, 0. So put in 0 for y and 0 for x. And you would have negative 2 times 0 is 0, minus 1, and is 0 less than or equal to negative 1? Well, no, it's not. So once again, we are going to shade in the opposite direction of 0, 0, which is out in this direction. Now, to finish, what we're going to do is look for our intersecting points. And where they're both shaded in, you can pretty much see, and we can draw using a different color here. This green area is our solution. Next, we have y is greater than or equal to negative 3x plus 1, and y is less than or equal to negative 3x minus 2. Let's go with the first inequality. Our y-intercept is at 1. And our slope of negative 3 means we're going to drop down 3 and go to the right 1. And again, down 3 to the right 1. We could also go up 3 and to the left 1. And we have a or equal to, so we can just draw in our solid line. And which direction are we going to shade here? Well, y is greater than or equal to negative 3x plus 1. We're not going through 0, 0, so we can use 0, 0 as our test point. And as you solve this out, is 0 greater than or equal to 1? Well, of course not, so we're going to shade in the opposite direction of 0, 0. Now our second inequality, we have a y-intercept of negative 2, and our slope again is negative 3. So we're going to drop down 3 and go to the right 1. We're also going to go up 3 to the left 1, up 3 to the left 1. And we once again have a solid line here. And we're again going to test 0, 0 here, as it does not pass through 0, 0. We can use that as our test point. Negative 3 times 0 is 0, minus 2. Is 0 less than or equal to negative 2? Well, no. So we're going to shade in the opposite direction of 0, 0, which is out in this direction. So when you solve a system of inequalities, you have to ask yourself, well, where's the intersection? Here, there is none. There is no intersection. And so our solution for this system of inequalities is just the null set symbol. There really is no solution. And today's math video is brought to you by the banana. Yes, the banana. Everybody's favorite fruit. In fact, Americans eat more bananas than any other fruit, with an average consumption of 26 2/10 pounds of bananas per year. In fact, Americans eat more bananas than apples and oranges combined. So go grab yourself a banana today. These and other fun facts about bananas can be found on todayifoundout.com. Please note, Mr. Richard's math videos are not sponsored by or endorsed by bananas, todayifoundout.com, or any banana producer. And now back to the math. A college service organization requires that its members maintain at least a 3.0 grade point average and volunteer at least 10 hours per week. So in Part A, define the variables and write a system of inequalities to represent the situation. Then graph the system, and once we're done with that, we'll name one possible solution. Well, for our variables, we can let G equal our grade point average. And we can let V equal the number of volunteer hours. Now for our inequalities, our GPA must be at least a 3.0. So we can say our G, our grade point average, must be greater than or equal to 3.0, because you can have a 3.0 and still be maintaining it. Our V for our volunteer hours, at least 10 hours per week, well, that's going to be greater than or equal to as well 10. So when we go to graph this, we've already started our graph here. You can see the 1, 2, 3, and 4 on the x-axis, so that's going to be our GPA. And for G will be our x-axis. Our 3.0 can just be drawn in as a vertical line going up from 3. And of course, a solid vertical line here. In which direction are we going to shade? Well, we want it to be greater than a 3.0, so it's going to go off to the right. What about our V is greater than or equal to 10? Well, we're going to draw here a horizontal line since our y-axis is going to be our volunteer hours. And once again, we'll draw a horizontal line across from 10. And we want at least 10, so we're going to be 10 or larger. And we can finish our system now by shading in where they both are true, which is up here in this green box. So when we're looking for one possible solution, we could go across to, say, 3.5 on our GPA and up to 12. And right here is a possible solution. So we could say 3.5, comma 12 as an ordered pair, which means a GPA, grade point average, of 3.5 and 12 hours volunteering. So as long as you're in the green area, you can be in this college service organization. That's it for this lesson. Good luck. Go ahead and grab yourself a banana. As my grandma used to say, they're good for your eyes.